write it down. Number 1, smaller mark. The sum of an arithmetic series where T1 equals -2, T3 equals 7, and n equals 15 is blank. That's number 1. Number 2, the 30th term in the sequence. These are aggressively large numbers, so I hope you enjoy them. 3,515,625, comma, 703,125, comma, 140,625, 28,125 is blank. Now, first one I told you is arithmetic, correct? Number 2, I just said sequence. So what's the first thing you're going to have to figure out? Yeah, if it's arithmetic, it'll have a common difference. If it's geometric, it will have a common ratio. You need to figure out which one it is. There's 2 TNs you could use. You need to figure out which one. That's 2. Then number 3. The sum of the geometric series 14 plus 70 plus 350 plus ... plus 4d3. This is continuing on. Sorry, I ran out of space. So it's 1470, 350, some dots, a plus sign, and then this is the last one. 43,750 is blank. So this one here says the sum of an arithmetic series where T1 equals -2, T3 equals 7, and n equals 15 is what? So in order to find the sum of an arithmetic series, there are 2 of them. There's one where I give you the last term. There's one sum where I give you D. The other non-negotiables are T1 and n. We agree? T1 and n are there. What don't we have? D. Or Tn, right? So we need to find something. When we're missing something, what must we use to find it? Yeah, the Tn formula, correct? So the Tn formula is Tn equals T1 plus n minus 1d. I don't know d. Now, what I can do is I can use T1 and T3, can't I? And just count 3 terms, not 15. So I'm going to do my last term as T3. So I'm going to do 7 equals my first, which is -2, plus 3 minus 1 times d. So I get 7 equals -2 plus 2d. Add 2. 9 equals 2d. Divide by 2. And d equals 4.5. I picked something specifically so that you couldn't just randomly guess. I'm kind of like that. So we had to use the Tn formula to get the d, correct? In arithmetic series, you have to watch, because sometimes I'm going to make you use the Tn formula to get another piece of information in order to use the essence. The great thing about arithmetic or geometric series is you can just use your formulas. Arithmetic is a little more cray-cray. So we need S15, and I'm going to use the formula with the d in it. So I'm going to get 15 over 2, bracket 2 times T1, T1 is -2, plus n minus 1, so 15 minus 1, and then d we found was 4.5. So I get 7.5, bracket -4, What's 14 times 4.5? 63?
Yeah.
I believe you.
63.
It's 63.
All I'm doing is 50.
So you get 7.5 times 59, which is
442.5.
You agree? Yeah. So this was a little bit harder of a question because you had to solve for your D first. So do a 7.5 times 59. 442.5. The next one I want the 30th term in the sequence. It's going from 3 million to 703,000. So I'm guessing it's a division. It's dropping substantially. Unless I'm subtracting by like 2 million each time, which I'm not. So I'm going to guess it's an R. If you don't know if it's an R, you can do D. You can go term 2 minus term 1, and then term 3 minus term 2, and you get the same thing, which you don't. So then I try R. So I'm going to go term 2, 703,125, divided by 3,515,625. And I hope it's the same as 140,625 divided by 703,125. I hope. If not, I messed up. So I do 703,125 divided by 3,515,625. And I get 0.2. Then I try the next one, 140,625 divided by 703,125, and I get 0.2. So I know that this is an R, so I know that this is geometric sequence. And it's a sequence, not a series, correct? I only have one option of a formula. It's Tn equals T1 and then times R to the n minus 1. What do I know? Well, I know T1. I know n. I know R. Boom. Right? So I'm going to do T30 equals T1, which is 3,515,625. It's a large number. Times 0.2 to the 30 minus 1. This needs to be done first. It's an exponent. So you need to go 0.2 to the power of 29 times 3,515,625. Wow, that's a large decimal. Something is wrong with my There we go. If you put nope, that's the lie. 0.2 to the 29 times. It gets really little, doesn't it? So I'm going to let you in on a little secret. This question, it's 1.89 times 10 to the negative 14. No. You have to do this first. So you have to go 0.2 to the 29 and then times it by that. If you don't put it in brackets, your calculator is going to multiply these first and then raise it to the 29, which doesn't work. Now this question had actually asked for the 8th term, and I was like, well, that's stupid, because once they find R, they can just multiply by 0.2 to the 8th term and get an answer. So I'm like, oh, Crystal, 230. And then I didn't think about the fact that would be a really small decimal. So I'll backfire a little bit there. But yeah. Okay. What did you think I was doing? Not the right one, but you know, still found R.
Yeah.
So here it says the sum of the geometric series. So I was nice. Boom, sum, geometric series. So I know I have two options. I have Sn equals T1 R to the n minus 1 over R minus 1. Or Sn equals R Tn minus T1 over R minus 1. And I will make the executive decision once I figure out what the heck I'm given. So, I'm given T1. Woohoo! That narrowed down nothing. Both of them have T1s. All right. Both of them need R's. I'm going to get R. So R is going to be 70 divided by 14. Hopefully it's the same as 350 divided by 70. Which should be 1/5. No, it should be 5.
Yeah.
Wow. I'm really thinking that's fractional. 5. Okay. Still didn't narrow down anything. Both of them have T1s and R's. One has a Tn, one has an N. Ah, what did they give me? Tn. What did they not give me? N. Boom. Done. Geometric series are so much nicer because if you're not given N, who cares? Use the other one. Arithmetic, if you're not given N, you have to use Tn to find N first, then be able to solve it, right? Because both of them have N's in it. Geometric, so nice. So, we're going to go Sn because I don't know how many terms there are, so I have to leave it as Sn. R is 5. Tn is 43,750 minus T1, which is over here, 14, all over 5 minus 1. If you don't use alpha y equals enter to type this in, you need to put them in brackets, top and bottom. You can put them in round brackets, or do the top separately, do the bottom separately, divide them. That one's the fractions is your foolproof one. Doing them separately is also foolproof. Brackets can make oopsies. But can work. 43,750. I keep messing up the number. Did you get 54,684?
Yep.
Okay, perfect. All right. So we're going to talk about quadratic functions. In grade 10, we talked about linear functions, which were lines. We're kind of done with them for a little while. We bring them back in 30, kind of bring them back in 20, but we're going to talk about quadratics. So what we dealt with last year was y equals mx plus b, and we indirectly did that in junior high all the time too. They kind of give us y equals mx plus b equations without kind of telling us they were y equals mx plus b equations. And last year we learned you can draw lines with them. So what we're going to do here is we're going to analyze quadratic functions as form y equals a, x minus p squared plus q, which looks confusing. It's not. And determine the vertex, domain, range, direction of opening, axis, symmetry, x and y intercepts. Boy, I really wish my calculator popped up right now. I forgot to do that on Friday. And right now, I really wish I hadn't. So, that's good. Following along verbally for everyone. I believe in you. You can do verbal commands. Yes. So, we're going to graph the function creating a table of values, which means we need to pay close attention. Okay? All right. So we're going to graph it with a table of values, then we'll show you how your calculator does it for you. It's such a wonderful, wonderful device. So, this can be our table of values. This is our x. This is our y. Because f of x is a fancy way of writing y. Okay? We're going to do a table of values. You guys were taught this. You were taught that whenever, like I could say y equals x squared. The reason why I use f of x is I could draw a whole bunch of x squared graphs on one graph. I could label one of them f of x, I could label one of them g of x, one of them h of x, and I could quickly label them all, and you'd know which one actually represented which equation. That's why we use f of x instead of y. If I just labeled them all y, I'd go y, and you'd be like, I don't know which one goes with what equation. But if I label one of them f of x and draw it and put a little f of x on the graph, and then one of them g of x and draw it and sketch a little g of x on the graph, you'll know which one's which, right? That's why we start using function notation when you draw more than one graph on a graph. But really, it's just a y. So we were taught in grade 10 to make t-tables. And we were actually taught in junior high to do this as well. So I can pick any x value and find the corresponding y value on the graph by just plugging it into the equation, right? So let's do something symmetrical. I'm going to start off with -3. Now you might say, why would you start off with -3? And I would say because I know to start off with -3. But I just want to pick some below and some above, some negatives and some positives. So because of the table looking like this, I'm going to go -3, 2, 1, 0, 1, 2, 3. That's why I picked -3. Okay? So I plug -3 in. Now, if I plug it into the equation, I'm going to get y equals, and whenever I substitute in anything, I said this before and I'll say it again, when you substitute in, you must put in brackets. Okay? Every time you substitute in, you put in brackets, because that forces it to go in there. So we're going to go negative 3 squared. Because if we don't put it in brackets, negative 3 squared not in brackets is actually negative 9, which is not true. We want negative 3 to be squared. So we want negative 3 times negative 3, which is actually positive 9. So my coordinate is at negative 3 and 9. I'm going to go plot that. Negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. I'm going to draw it off the graph. What's another way I can do it so I don't draw it off the graph? Make, not my x-axis, my y-axis. My y-axis go up by 2. So I'm going to say y scale down here of 2. So that I don't have to go 2, 4, 6, 8 and label it. If I just go y scale of 2, it's an assumed 2, 4, 6, 8. Okay? So I want it negative 3 and 9. So I'm going to go 2, 4, 6, 8, 9. Plot it. Then I want to find the next one. Negative 2. So I'm going to go y equals negative 2 squared, which is positive 4. Because negative 2 squared just means negative 2 times negative 2. So I'm going to go negative 2 and 4. 1, 2, 3, 4. That's a lie. This is what you have to watch yourself to not do. I just counted them as ones. And what's my y scale?
2.
Sometimes I would like to pretend I did that to prove a point, but that was just, no, that was just stupidity. So, negative 2, 2, 4. So always remember, once you plot your scale, and then my x scale I'm making be 1. So when they're different, sometimes I forget. So sometimes you'll forget, so don't forget. Then I do negative 1. Y equals negative 1 squared. What's negative 1 squared? 1. So I'm at negative 1 and 1. Ah, come on, Lepp. Adjust. Seriously, it's hard to adjust and not doing them as ones all the time. And then we do 0. Y equals 0 squared. This one's easy because I can't screw it up. It's the origin. The origin is 0, 0. That's what it's called. And then I do 1. Y equals 1 squared, which is still 1. What's happening here? Yeah, it's actually symmetrical. Why is it symmetrical? Why am I getting the same y's? Why am I getting the same y's? What does the squared do? Yeah, it makes the negatives positive, and the positives already stay positive, right? So if I go negative 1 squared, it's positive 1. If I go positive 1 squared, it's positive 1. So because these are squares, which is called a quadratic function, because of that, you get it symmetrical, because whether I square negative 1 or I square positive 1, I'm going to get the same answer on both sides. So it makes a symmetrical deal. So if I do 2, it's going to be y equals 2 squared instead of negative 2 squared, but still 4. And then I do 3, which is still 9. And then I connect them. Now this doesn't make a perfect V. This is not a point down here. It's rounded. So you're going to come down, pass through it, and then you round the bottom, and then come back up. Pretend that that's actually perfectly through that. It's Now we're going to type it in and actually look at it. Ready? This is where I need all your brain cells, because sometimes you don't remember your grade 10 stuff. Okay? Sometimes it fell out. Sometimes it didn't go in. You know, there's options. But we don't care, because we're starting fresh. I'm going to sit. Y equals button. Press it. And then we're going to press x squared, because that's what we're drawing here, correct? So we're going to press the x t theta n button and the squared button. So you can either press the squared, which is below math 2 buttons, or you can press the little roof symbol below clear and then 2, right? Gets you the same thing. I'm pressing the 1, 2 below math because it's faster. Now, what did I tell you? How do you reset your calculator so your window goes back to negative 10, 10, negative 10, 10? Zoom 6. It's a magical button. There's two of them. There it is. You're lost? Go to y equals. Then go x. And then press the square button. So you either press the roof and then 2. Or you press the button 2 below math. And then zoom. Very top middle button. 6. So does it look like what's in front of us? Who said no? You have one of those calculators.
I'm a Casio.
I know.
It works differently.
I agree with you.
I need like XM, what is it, like XM plus B or something.
Nope, that's not what you need.
AX plus B or something.
Nope, that's linear.
Squared. Yeah, linear.
Yeah, you don't need that. You need quadratic. I'll come try and help you in a few seconds. Yes. Okay, so we have the graph in front of us. Yes? Most of us. I will be over there, Carson, in a second to try and help you. So, we have y equals. We agree? You're in the same boat, hey? It's a sinking boat. I don't know how to help it, but I will try and help it in a second. There is an easy way to put it in. I just can't remember. I have to quote it. You have that in front of you? Now go second mode. Unless you're, of course, not me people. But you do have a mode too in Casio. So you go second mode, and it takes you off, puts you on the main screen, correct? Now you don't have to go zoom 6 to see it. You don't have to do that. That was just to get your window back. If you want to see whatever you type into your y equals, you just press the graph button, which is completely on the opposite side of the y equals. You found it?
Maybe.
Okay. We will find out in a second.
Yeah.
So do you see the graph button? It graphs it. Yeah? Now you see how we did this work to get this table of values right here? See how we did all that work? Our calculator's miraculous. It does all the work for us. So we're going to press graph to see it, correct? But we're going to press second graph, because what's the word above graph?
Table.
Table. And what did it give us? A table. You can arrow up and see more. You can arrow down and see less. Don't hold the arrow to see if it ever ends. It doesn't. That's not a challenge. There will always be someone. Caleb, you're that someone. Stop it. No, it doesn't. I trust. Dude, doing this since 2006. It doesn't end. Oh, dang it.
That's tough.
That's sad. That's worse than a Casio right now. That thing's dead. Your doorbell. Why do they say dead like a doorbell? How many doorbells are dead? Is a dead doorbell like that? Why is that a saying? I just realized. All right. Do you have it showing up?
I just spun them and it turned on.
Yeah. It'll last for a little longer.
Like 120.
Yeah, probably not. Okay. Do you have that? Do you see how it gives you the table of values? Isn't it beautiful? Isn't it worth the money? It is. Okay. What? I'm not going to tell you how to reset it, so this is going to take you the same amount of time to get back up. Okay. Stop it.
How did you reset it though?
I'm not telling you.
I really want to know.
No. So on this one, we're going to come back to the table of, we're going to fill in the rest of that, like all the vertex, all that stuff. We will do that in a second. But we're just going to practice using our calculators because I know that some people don't, and some people don't know how to use it, and the Casios are going to come help. So I want you, you're not going to fill in this table. You guys, you're not going to fill in this table at all right now. We're not doing a table of values at all. Are we following? No tables of values. Do not fill these in. This is not a table of values. It's going to be vertex. We're going to fill in all this information. We're just not doing that right now. Over here, all I want you to do is graph this. So into our y equals, we're going to type 2x squared. Carson, I'll be right there. Just put down your calculator for a few seconds. So we're going to go y equals 2x squared. Okay? And then how do we get our values? Second graph will give us our table of values. We can plot the points. Okay? If not, you can press graph just to see how it's going to be. So you're going to plot that. You're going to try and graph it in one color. And then you're going to clear out y1. You're going to put that in and try and graph it in another color. Or use stars for one of them and dots for another. But you're going to graph both of them on here. When you put the half in, use alpha y equals enter to put the half in. Or you have to put it in brackets because that's the only way your calculator knows it's a fraction. So you either use the alpha y equals enter to use it as a fraction, or type it in brackets. When we type in y equals 2x squared, we go second table, and I'm going to make my y scale be 2 again, and my x scale be 1. So I go to negative 4 and 32, which is not helpful to me. Then I go negative 3 and 18, 2, 4, 6, 8, 10, 12, 14, 16, 18. Well, that would be up here somewhere. I should have made this bigger. Negative 2 and 8, 2, 4, 6, 8. And then I have negative 1 and 2, 0, 0. Then it's going to be symmetrical. Oh, I did the 2 thing again. Why didn't anyone correct me? Hello. Holla. They're worth 2 each. I made the y scale worth 2 and then made them put it at 4. Good work. So you just pull those off your table of values. Like if you typed into your calculator y equals 2x squared by itself, and then you went second, graph, and you pulled coordinates off of it. And you just graphed them. Right? Not doing any of that right now. We're just graphing it. We're not doing. I said, do not fill in this chart. That's what I just said. And then I said, put 2 graphs on there. Well, that was it. Okay. So this is y equals 2x squared. And then I'm going to do another one. So, 1/2 x squared. And I get really tiny numbers. Okay, so I get negative 4 and 8. 2, 4, 6, 8. And then I scroll down and I'm getting negative 3 and 4.5. Negative 3 and 2, 4.5. And then I get negative 2 and 2. And then I get negative 1 and 0.5. And then I get 0, 0.
Is that what the 9, like, divided by 2? Like, I was really confused. So it gave me, like, can you remember, like, my calculator?
9 divided by 2 is 4.5.
I didn't know that.
So if your calculator is coming up in fractions, you can go second table set. Go to mode, and then you go down to answers in decimals. Series gaps. Just good. Yeah, you can just decimal themselves. If you want to not have decimals, or maybe you don't want to have fractions, you just put it in as a fraction. If you use the fraction button, it'll give you fraction answers in your table. If you just put 1/2 in as not fractions like this,
Like,
it'll give you decimals.
like I did 1 divided by 2.
In brackets, yeah. Okay, so just so you know, Caleb's asking a good question here. If you put it in fraction, like if you go y equals, or second y, alpha y equals enter, and you put it in as a fraction, your table of values will show up as fractions. If you put it in as a bracket 1/2 x squared, your table of value will show up as decimals. So it depends on how you want your table of values to show up. So then these are symmetrical, so it's going to go here, then here, then here. So what happens, you guys, this is y equals 1/2 x squared. If I put x squared in here, I'm just going to put the original back into this one. So y equals x squared is at 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and 3, 9. So I'm just sketching, this is the x squared graph. This is the original. Just showing it to you guys just so you can see it. So what happened when I put in front of the x squared a number that was greater than 1? It got narrower, right? Because it took all my y values and it pulled them upwards faster. So it got taller faster. And then when my value in front was between 0 and 1, it actually got wider because it took all my y values and it squished them by half. So if you squish your y values by half, it means that they're not going to get as fast. So it's going to grow half as fast. So it makes it actually wider. Okay? Lovely. Great. Did you just know how to graph the graphs? Did that make sense to you? We're following that? Okay, we're going to go back and we're going to fill in the chart. And we're going to learn information so that we can fill in the chart. It's crazy. Okay. What in the heck is the word vertex? What in the heck is the word vertex? Anyone know? It's a coordinate, yeah. Yeah, but what is it? What point is it on the graph? Yeah. It's what? For both sides meet up. The vertex is either your lowest point or your highest point. Because the parabolas, these are called parabolas, are concave up currently, right? They will end up being concave down as well. So this one's concave up. When they're concave up, your vertex is actually the minimum. But what we're going to write over here is our vertex, let's do anything, is our max or our min. So the highest point is the lowest point. And in this case, it's our lowest point. What is it at? 0, 0. Now to find our vertex, we're going to find our max or our min. Okay? How the heck do we do that? We're going to go, this one just showed up for us. We could see it, right? Because we graphed it when it's 0, 0. I'll show you how to find your minimum. Ready? And we'll practice this after today too, but I'm just going to show you how. So we want to calculate something. We want to calculate a minimum. Do we agree? If we want to calculate something with these fancy calculators, how we calculate something is we press second. Sorry, go back to your y equals first and put in x squared, because you probably don't have that in there. Go to your y equals and put in just x squared, because we're going back to this graph, right? Did everyone have that in your y equals? The graph showing up? So we're going to go second, and then we're going to press trace, because what's the word above trace? This is going to be one of our favorite places to go. You know, like when you're like, ooh, I really like Mexico or Hawaii. This is actually your favorite place to go. Second, and then the trace button. And then what perchance do you think we might pick?
3.
3, minimum. Now, what does it say at the bottom of the screen? Left bound. So we need to use our little arrows and be on the left somewhere of the minimum. So I just arrow over till my blinker's somewhere on the left. Is your blinker somewhere on the left?
Can it be anywhere?
Anywhere on the left. It just needs to be on the left of it.
That's so cool.
Okay?
We can go
Then-
so like.
Stop it. Just be on the left somewhere.
It's like a little roller coaster.
This is going to be a problem. Oh my goodness. Okie dokie. Okay, we're on the left somewhere, anywhere? On the left. Not your other left, which is your right. No, your rights and your lefts. Are you on the actual left?
Yes.
Okay, hit enter. Now what does it say? Right bound. Where do you suppose we're going to go now?
To the right. Oh.
To the right. To
Roller
the right.
coaster.
To the right of the minimum. This is not nearly as fun as you're making it out to be, but I'm glad that you're liking it. So you need to be on the right somewhere. You could be right on the right of the minimum or way up top on the right of the minimum. You just need to be on the right. You got that? Then hit enter again. Then it says guess, and for some reason it makes you press enter again. I don't know. Press enter so you can guess. What does it tell us?
Minimums.
Some people have 0, 0 sitting in front of their face. Mine does not. Mine has 1.257 e to the negative 6 and 1.5 e to the negative 12. What does e to the negative 6 and e to the negative 12 mean?
Times
10.
10.
It's 10 to the negative 6. So
I-
x is at 0.00000125. What can we round that to? 0.0000. If I were to go to a whole number, what would you round that to? 0. 0.00001 is 0, correct? Yeah. Okay, the other one is 1.5 e to the negative 12. So it's 0.11 zeros, 158. What would you round that to? 0. When you see e to the negative anythings, that's 0. Don't give me the answer 1.3 and 1.6. Just X. Do you hear me? If it is e to the negative anything, what answer are you going to give me? 0. That's it. You're not going to give me scientific notation. You're not going to give me rounded 1.3. You're not going to give me, you're going to give me 0. Because where is my minimum at? 0, 0. What does your calculator say? E to the negative 6, e to the negative 12. So it's saying 0, 0. Don't give me any other answers. If you see e to the negative anything, your answer is 0. Please do not give me anything else. Stop the madness. Okay? Do we understand the vertex? Okay. What's the direction of the opening? Up. Yes, it is. It's up. Crazy snakes, but that's what it is. It is up. Are you ready? Axis of symmetry. The axis of symmetry is if I folded this bad boy in half, where the heck would the vertical line be? So if I took it, you know, do you remember in elementary school when you folded a piece of paper and you cut out half a heart and then it folded open and you had a full heart? You know that fold line? It's called the axis of symmetry. No one just told you that. Because they just said, hey, there's a fold line, here's a heart. Or it didn't look like a heart at all and you really sucked at that job, but whatever. Nonetheless, axis of symmetry of a heart or a flower or nothing. I don't know what it happens to be sometimes. It's the axis of symmetry, yes. So this one, what line cuts this baby in half? The y-axis, correct? Which is actually called the axis of symmetry, whatever this line is that cuts it in half. What's cool about it is it's the x of the vertex. Is it not? It's also an equation. So it's always x equals, and then whatever the heck the x of the vertex is. What's the x of this vertex? What's the number in the x of the vertex? 0, because this is xy, correct? So it's x equals 0. It's just the x of the vertex. It has to be x equals because it's a line. Do we agree? Sure. We'll go with that. Down here. So look, we have 0, 0, we have up, we have axis of symmetry is x equals 0. Not gonna worry about domain and range right now. You guys crumble inside and die. It's fine. It's really not as bad as you thought it was. I don't know, in grade 10, it's like you guys can't do it. Domain range. It's just something else. But you're not there anymore. Your head is here, and it is big brained. So we're fine. We're gonna type now. We're gonna go to y equals, and we're gonna clear out 2x squared. What's up?
Okay, so for the things, which
We're not doing inequalities right now.
okay.
Nope, not going there. We're not, not alligatoring anything. Okay, we're going to go to our y equals and we're going to clear it out. And we're going to type in 2x squared. So you go to y equals, you press clear. You're going to type in 2x squared. And these graphs are all concave up, correct? Up, up. They're up because these are positives, just so you know. You'll figure that out in a second, but they're up because it's positives. So you're just typing in the 2x squared. You're pressing graph. We want to find the vertex. What's the vertex in this case? A min or a max?
Min.
Min. So how do we do it? We go second, trace, min, which is number 3. And then it says left bound. And we're not going to rebel against the machine. We're going to go left bound. It's crazy. We're on the left. We're going to hit enter. And then it says right bound. And we're going to go to the right. And we're going to hit enter. And then it says yes. And we just say okay. And you press enter. And what does it give you? Ease.
0.
With negative somethings. So what is it at?
0.
0, 0. What's it at? They're both at 0, 0. We drew them already. We agree? So this one's at 0, 0. What's the 1/2 x squared going to be at? 0, 0. What's the axis of symmetry going to be at? X of the vertex. The vertex's x is 0. Please don't write just 0. It's an equation. It has to be x equals 0. We're not here yet, but I'm going to make you do it anyways because we're on a practicing situation. So you're going to type into your calculator y equals 2x squared plus 1. Go. So you're going to go to your y equals and you're going to clear that bad boy out. We're going to press clear. And then we're going to go 2. My big fat head's in front of it. X squared plus 1. And we press graph. And we look at it. Is it on 0, 0 now?
No.
Is it concave up? Yeah. Is it a minimum? Yeah, it's still a minimum, right?
Mm-hmm.
So we're going to, how do we find that vertex? Second, trace. Number 3. It says left bound, we hit enter. It says right bound, we hit enter when we move to the right. And then we press guess. And what do we get? Y equal to 1, and what's my x equal to?
E negative 6.
Either the negative 6 or either the negative 7, which is 0. So my vertex for this one is at 0, 1. What's my axis of symmetry? X equals 0. We agree? Okay, go to your y equals, clear it out. You haven't noticed I'm drilling this home here. Y equals x plus 3 in brackets squared minus 1. Yes, it will get to be like this. So type that in. Exactly how it's written. Clear out your y equals and type in bracket x plus 3 squared minus 1. Press graph. Is it at 0, 0 still? Certainly doesn't look like it. Is it concave up still? Yeah. Is it a minimum still? So can we do second trace vertex? Is there a button that says vertex? Does there exist such a thing? Trick question. No. No, you got the X in it.
No, so why is it a line for something?
We're looking for the vertex. So we're looking for the min or the max. It says on there, you can just pick it, Karsten. On the bottom, if you look, yours says min or max. You just pick minimum, and it'll tell you. Yeah. So you're going to go second trace minimum. The only way we can get vertex is by picking min or max. There's no vertex button. And the reason why is we don't just do quadratics. Next year we're going to do other ones. So you go second trace minimum. You need to be on the left side of it. Enter. Right side of it. Enter. Enter. What's my vertex at? I got negative 2.99999. I'm going to say 3. Negative 3. And negative 1. What's my axis of symmetry at? You might not have typed it in right. Axis of symmetry is x equals negative 3. It's whatever the x of the vertex is, and the x isn't 0 anymore. That is it. Now homework. You can do that review I gave you on Friday. You can work on that bad boy. Do some extra review.